we were talking about Tesla cars, and we were talking about how it'd be nice to have one, right? Um, and we had said, you plug that Tesla car in, and a battery builds up a rechargeable battery, a lithium ion battery, builds up the charge, and then you can speed down the road for about 270 miles. And so Tesla cars use lithium ion batteries, and this is the same kind of battery that's in your cell phone. Now, what do you hear about? Sometimes you hear about problems with people with their cell phones. I remember seeing some stories where I guess some people plug their cell phones in, and they sleep with it under their pillow, and there occasionally will be what? There'll be a fire under your pillow. That's not a good thing. You don't want that. And the problem with that is that the lithium ion batteries, what they'll do is if that separator breaks down, you can then end up with a release of the oxygen gas, which can lead to a fire. It's the same thing that we see with airplanes. They're really funny about lithium batteries, because when you're up there, you don't want to have a fire. It could be ugly. So anyway, that's a downside to lithium ion batteries. Now, one of the things you need, like we had said that Tesla, because of all those batteries, it takes a lot of them to produce 779 brake horsepower. It takes a whole lot of them to produce that kind of horsepower, and they weigh a lot. And so in order to overcome that weight, to get going, they use something called a capacitor. And what a capacitor does is it's used to store static electricity. So you walk across the room, and you basically have become a capacitor, and you touch your neighbor and it goes snap and you shock them. Well, that is a very rapid release of the capacitance. It's the amount of built up electric charge. Now, one of the things that when they were developing this electric car technology, they had to figure out, how can we have a lot of rapidly available energy that is controlled? And so they've really done a lot of work with capacitors, and they've developed super capacitors. And what these are is they have a very high capacitance, and they can, the difficulty, as you might know, when you snap someone with that shock from walking across the carpet, and where you've built up a charge, it all goes at once. But they've figured out how to harness that electricity and release it in a controlled manner. And these super capacitors are what are used in Teslas and things like that to get them moving. So you need just an extra bit of power to overcome the weight of those batteries. I know it's way before you guys, but it used to be before we had fuel injection. You had a thing that was called a distributor, and it distributed the charge from the spark, and it had a capacitor in there, and sometimes it also had a capacitor in there, and sometimes people would play around with them, and you could charge them up, and they would basically explode. Play jokes on people. It didn't hurt you, but it would surprise you. Okay, so what happens that in these cars, these hybrids and these electric cars, we're going to be looking at the use of batteries and super capacitors. So you have the battery for, to have the charge, and then you have this stored extra charge that's in this super capacitor.